Because of the fires that burn at 1800 degrees Fahrenheit in the Wilmarth boilers, because of the steady supply of fuel, refuse-derived fuel, garbage, the NSP Wilmarth plant plays a vital role in Minnesota. The people who run the plant provide electrical energy. Even more importantly, they help us reduce a huge landfill problem. Think of it this way, as the ultimate in productive recycling. The cereal boxes you bought last week and put in the garbage when you finish them this week become the fuel that generates the electricity that helps to manufacture the cereal boxes you'll buy next week. A full circle of energy savings. How do we turn garbage into electrical energy? The fuel we use, garbage or RDF, heats water into steam. The steam turns large turbines, large fans if you will. They turn a generator, a coil inside a huge magnet, which produces electrical energy. Before 1986, Wilmarth used coal to provide the heat. In 86 and 87, the plant was converted so the boilers could handle refuse-derived fuel. We burn over 200,000 tons a year, producing 22 megawatts of power, supplying the electrical needs of over 20,000 homes. That's a lot of energy. That's a lot of garbage. Where does it come from? How do we get it to burn? Do we burn all of it? The garbage comes from you, your neighbors, their neighbors, nearby counties in the state. It comes to the waste processing transfer station on the south side of our plant. Most of it is taken to processing centers like the NSP Newport RDF facility. After weighing in, the trucks place the collected garbage on what's called the tipping room floor. Some of the materials can't be burned and must be put in landfills. But most of the garbage is placed on conveyor systems. Traveling up the conveyors, they pass a powerful magnet that removes the metal items for recycling, leaving the burnable RDF. What hasn't been separated continues up the conveyor system, where an air knife, a high-pressure air stream, cuts and dries combustible materials. What was garbage becomes fuel, refuse-derived fuel, light, dry, easy to burn. Trucks haul the fuel to Wilmarth, where it provides electrical energy to those 20,000 homes. At the plant, the truckers place the fuel directly on the conveyor belts to take it to the boilers, or they put it on the tipping room floor for later use. As the fuel is needed, plant workers move it from the floor to the conveyor system and into the boilers. Coming directly from the truckers or from the tipping room floor, the RDF first goes to the scalping conveyor that levels the fuel load. Control room operators monitor cameras tracking the fuel on the conveyor before they drop it into transfer belts below. From there, the fuel goes to the plant where it free falls into the distribution conveyor. Then the RDF goes into the 4 metering bins below. Moving slide gates meter the fuel onto a bed of rotating screw augers. The augers pull the fuel to the pant leg drop chute where it falls into the mouth of the boiler. Windswept spout air throws the fluffy RDF to the back of the boiler grates. As the boiler grates move forward, a combination of overfire and underfire air creates optimum combustion. Like your fireplace at home, most of the fuel is burned, but there is some ash left. The RDF is burned and reduced to 15% ash, which falls into a submerged conveyor and goes to the ash building. Unlike your fireplace at home, we treat and filter all flue gas that comes out of the chimney. NSP monitors and periodically tests the flue gas in accordance with federal and state required air quality standards. We run combustion gases through a scrubber system, spraying a lime slurry onto the flue gas stream to neutralize any acid gases. Then, with huge draft fans, we pull the gases through 2 pulse jet bag houses, each containing 1,260 bags. Fly ash particles collect on the outside of the bags. By applying a predetermined difference in pressure between the inside and outside of the bags, we clean the bags, causing the collected fly ash to drop into hoppers below. There, ash is conveyed to a bulk mixer where it's mixed with water for easy, dust-free removal. The ash is then placed with the bottom ash and trucked to our state-of-the-art ash monofill. NSP's monofill, where only one product may be stored, is located near the Ponderosa landfill. State-of-the-art means nothing's going to leach through the ash to affect the groundwater. It means a double liner with leak detection, a 3-foot clay barrier, a 2-foot sand drainage layer. It means a leachate collection system that gathers all rainwater filtering through the ash and the moisture from the ash itself. It means collecting and testing the leachate water every month and reporting the results to the MPCA. When we've filled one of the landfill cells, we cap them with another liner and 2 feet of cover soil. We seed them with grass and vegetation, and we continue to monitor to assure minimal environmental impact. That philosophy is true in all aspects of plant operation. The people who run the plant continuously monitor for opacity, carbon monoxide, carbon dioxide, excess oxygen levels, sulfur dioxide, nitrogen oxide. They test periodically for particulates and hydrogen chloride. They know the value professional clean operations provide to the community. They're well aware of the dual role they have, helping us all benefit by reducing the amount of municipal solid waste that goes into landfills, and at the same time, providing electrical energy for 20,000 households. So the next time you fill up the garbage container, remember, you're not adding to a landfill, and you may be providing a source of energy to turn on your lights next week. The Wilmarth Power Plant and NSP, the energy to make things better.